Hello everyone, welcome back. Hope you're all having an amazing day. In our last video, we took a look at how to use OpenAI in Azure and provided an overview of all the different services that are available. And today we're going to be looking at how we can connect ChatGPT to your enterprise data. You might be asking, isn't it as simple as retraining? For instance, all of the modeling work that you might have done in the past involves simply adding additional data, relabeling the data, and retraining. So that's your traditional modeling approach that you may have worked with. However, working with ChatGPT is a different story. These are large language models, and their weights themselves can be as much as nearly 1 terabyte. And they've trained on quite a bit of data, several gigabytes, even terabytes worth of data. So retraining from scratch, in addition with your data added on, can be even larger, and ultimately can be extremely expensive, where the cost could range from literally a few $1,000,000 per training iteration. And not only is it expensive, it also need to set up the appropriate GPU clusters, large clusters to handle your data, and you need expertise to work with the right frameworks to make that distributed training possible. And also, obviously, you're going to have a lack of data, not your own data, but the lack of the original training data that was used to train the GPT-3 family of models. So the several terabytes of data that was used in the original training. So for these two reasons, simply retraining a ChatGPT model is not possible. And you might be thinking, what about fine-tuning? I've heard about this fine-tuning that's available. At this time, ChatGPT, both 3.5 Turbo model and the GPT-4 model, did not allow for fine-tuning. And also, ChatGPT is already a fine-tuned model. So ChatGPT was trained on several human-generated question and answer pairs to create a natural conversation. So the model is already fine-tuned, and generally, you would not want to fine-tune an already fine-tuned model, as you would lose some of the benefits of the original fine-tuning. And just to give you an idea of fine-tuning, the process of adapting a original GPT-3 model to a specific task, such as chatbot development, which ChatGPT is, and you can also perform other types of fine-tuning as well. You can actually perform fine-tuning for some of the base models, the GPT-3 family of models, such as DaVinci, Curie, Babbage, and Ada. And if you want to fine-tune these, you can actually perform task-specific type of training using a very specialized data set. And the process of fine-tuning ultimately involves updating the weights of these pre-trained models with the new data, allowing it to learn how to generate more relevant and appropriate responses for a given specific task. In the case of ChatGPT, the model, as I mentioned, is already fine-tuned on conversational data. And really, ultimately, the main benefit is that it allows the model to behave in a more human-like responses by providing human-like responses to human queries. And it also allows the model to understand context of the conversations. And you can also fine-tune the existing DaVinci, Curie, Babbage, or Ada models for specific tasks, such as classification or intent entity extraction, and various other very industry or use case specific tasks. But generally speaking, using fine-tuning for Q&A knowledge retrieval is not ideal. And this is because your enterprise data is constantly changing. You might have new policies, for instance, being added, or new workflows or new data being generated on a daily basis, and you may have thousands of documents that are updated on a daily basis. So fine-tuning on a schedule on a daily basis or weekly basis is not very practical and can be very expensive, and you won't have access to the latest updates. If your training iteration is or like the fine-tuning iteration is on say like a weekly or monthly schedule, then you are not going to have the best experience. Not only is ChatGPT likely going to not perform as well for Q&A type scenarios, retrieval scenarios, but you will also not be able to retrieve the latest information that's available. So the question is, how do we overcome the limitation of not being able to fine-tune ChatGPT? So there are two approaches. The first approach, and this is the approach that is going to be that I'm going to be focusing on in this video, is using a search service such as Azure Cognitive Search. And the second is the approach of using vector embeddings, or creating a vector search using some of the OpenAI models themselves, such as text or search ADA models, which convert text into a vector representation, and then ultimately we'd store these vectors into a vector database, and then when a new query comes in, we're converting that query into a vector once again and comparing the vector similarity using cosine similarity function. So what this means is you have two vectors. For instance, let's just take apples and oranges and hamburger. So we have three words, and these are going to get converted into float point numbers or vectors. And they're going to be capturing, the idea here is we're capturing the semantic similarity. So all three, what they have in common is that they're a food group. However, apples and oranges are likely going to have a higher score, or in three-dimensional space, if these vectors were to be represented, the distance between apple and oranges will be smaller than, say, apple and burger or orange and burger. So smaller the angle between these two angles, the closer they are related. And that's pretty much the semantic search for embeddings in a nutshell. When we are talking about Azure Cognitive Search, it's a little bit different. It is using semantic search, but there are two parts to it. The first part is a TF-IDF-based keyword ranking, which is more of a classical statistical method of scoring similar documents. So you'd have 50 documents being retrieved when a user query comes in based on TF-IDF. And then you'd perform semantic re-ranking using the deep learning models in the backend to re-rank the results based on the first 50 that were presented. So this can be enabled, and you'll be able to retrieve more intelligent, semantically similar responses when semantic search is enabled for cognitive search. But ultimately, what both of these methods have in common is we'd need to extract unstructured information from various different document sources. So perform OCR, perform the right chunking strategy, and really we're just using these two approaches to overcome the one of the other limitation is the amount of information that can be fit into a prompt. So GPT-3.5 has a 4K limitation, and GPT-4 has the 8K and 32K token limitations. So with GPT-4, you can handle a lot more information within the prompt. Whereas using GPT-3.5, you would have to organize your chunking strategy accordingly so that the information actually fits. So whatever information that's retrieved from these search services will actually fit inside the prompt of the ChatGPT. So if we're retrieving, let's say, the top, ultimately we want to use, say, the top 5 results from our search query. So that could end up, easily taking up to 2,000 or 3,000 tokens, depending on the strategy that we use to chunk our documents. So a bit about the actual cognitive search service on Azure. So ultimately, it's a cloud search service that gives developers the infrastructure, APIs, and tools for building rich search experience over our private heterogeneous data. And heterogeneous in this case means PDFs, Word documents, JSONs, text files, etc. And ultimately, we need to build that search integration into different applications such as web, mobile, or enterprise type applications. And search is foundational to any app that really surfaces text to users, where some common scenarios could include cataloging, document search, online retail apps, or data exploration over proprietary content. And there are two concepts that are relevant to cognitive search. And these are the two primary workloads as well, which are called indexing and querying. The concept of indexing is essentially the intake process that loads content into your search service and makes it searchable. And internally, the incoming text is processed into tokens and stored in inverted indices for fast scans. You can also upload JSON documents or use an indexer to serialize your data into JSON. There's also the AI enrichment through cognitive skills, which is an extension of indexing. If your content needs image or language analysis before it can be indexed, AI enrichment can extract text that is embedded in these application files. For example, you can perform OCR on PDF documents or translate the text from, say, French to English or vice versa, and also inference the text and structure from non-text files by analyzing the content. So various different ways you can apply AI to index your content. And the second step is, once you've indexed and have your knowledge base available, then you want to query that knowledge base. So this querying happens only after the index is performed. So you have all your documents, all that information is stored in your index, and it's made searchable. So once that is searchable, then you can provide user queries, retrieve the information using BM25, which is a term frequency inverse document frequency type algorithm, classical algorithm for scoring. Generally, we have the top 50 results that are being retrieved from a user query, and then we're applying the semantic layer on top to re-rank the results based on semantic similarity. And ultimately, that is what is presented to the user, the top 50 semantically re-ranked documents. And a bit about the semantic search. So when semantic search is enabled, you have, of course, the semantic re-ranking that I was mentioning earlier. You can also semantically have answers being generated to your query. So in this image here, if you're asking, what is the capital of France? And the semantic model actually tries to answer the question directly by saying Paris is the capital, and also highlights all the keywords, Paris, capital, France, using semantic captioning. And if you were to make a spelling mistake in your query, that's also accounted for. So it performs spell checks, and there's a lot more intelligence happening in the backend, but ultimately it is going to try to attempt to answer if it detects that a query is a type of question and there is really like one answer to it. It'll try to highlight that answer for you. But also you have your semantically re-ranked results. You have 50 different results being provided for you. And the whole idea here is to use that 50 documents that are retrieved to pass them on to our ChatGPT API so that we can get answers from our queries and have ChatGPT actually analyze the answer that are retrieved from the cognitive search and then reply accordingly to the user. This architecture diagram is based on the end-to-end demo example Accelerator that's available as a repo. I'll demo that very shortly, but before getting into that, I'd like to go over the architecture. The architecture here involves a couple of pieces. So we have the Azure Cognitive Search, and we have the OpenAI ChatGPT and the Text DaVinci 3 model as well. And then we have an app orchestrator and UI that we can present our queries into. The first step here is actually performing the OCR on PDF documents and load them into our Azure Cognitive Search. So you're parsing the documents, and then we're also chunking the text to fit within ChatGPT limits, because this particular repo is still utilizing ChatGPT 3.5, so it has that 4K token limit. So we're chunking the document accordingly, for example, by page within each of the PDF documents. And ultimately, that inverted index is created from the documents that we upload into Cognitive Search. Next, user query is going to be passed on through our interface. And of course, you have your web app or container instance kind of orchestrating the entire flow of information. But ultimately, that query is passed on to Cognitive Search, where, as I mentioned before, the very first step is the BM25 TF-IDF-based document retrieval. So the top 50 documents are retrieved using the BM25 algorithm, and then the semantic models re-rank the top 50 results to really present the most semantically relevant documents to the user. But in this case, we can choose to retrieve just, let's say, 3 to 5 or a smaller amount of documents, because we ultimately want that information to be able to fit inside the prompt or the token limit of ChatGPT. And finally, that information that we retrieved from the cognitive search based on our own data sources, let's say the 3 documents, will be then passed on to ChatGPT for the answering, and that response is returned back to the user. And in the backend, all of the questions and answers are being stored. And let's say there's a second query that's coming in. So you have a second query from the user, and based on the past conversation history and the answers previously provided, we're using the text DaVinci 3 model to synthetically generate a new query, and that new query will then be passed on into cognitive search. So this is where the GPT-3 text DaVinci 3 model will summarize the information based on historical context and then pass on a new query for Azure Cognitive Search. And ultimately, that information is then returned back to ChatGPT, and then using that information, ChatGPT will generate an appropriate response back to the user. So it's a bit of integration of both ChatGPT and GPT-3 for synthetically creating queries against cognitive search. But ultimately, all of these different services work together to really give you the answers that you need based on your own industry data or your own enterprise data. So this is the sample repository that allows you to spin up a full end-to-end demo using cognitive search in OpenAI. And you can really use some of the example code bases to build your own application using some of the sample Python scripts, or you can just spin this up as a one-click deploy using GitHub code spaces or VS Code remote containers. I have not used those 2 services, but I have done a local deployment. So I installed all of the tooling such as Python, Node.js, Git, PowerShell, and the Azure Developer CLI, and I locally deployed all the resources that are required. So there are also bicep templates as well that you can use to customize your deployment. Or you can just use existing resources. For instance, if you already have a OpenAI service, or an existing deployment of the ChatGPT or the DaVinci model, then you can use those existing deployment endpoints as well. And all the instructions are up to date, so this should work as is. So if you were to run this locally, you would do the Azure Developer login, and then follow the instructions, change it to the app directory, and start the PowerShell script. And that should pretty much guide you through that process, the deployment process. And once the deployment is complete, you'll get the endpoint, the website endpoint, the Azure website, where the demo application will be provisioned. And taking a look at the repository, there are some sample notebooks that you can use to understand how the functionality works, the chat, read, and retrieve, how ChatGPT and Azure Search are communicating with each other. And some of the scripts will kind of allow you to understand that logic of information retrieval. And there's also the bicep templates that are available. So for example, for cognitive services, you have some sample templates which will spin up that form recognizer service, which will help OCR some of the PDF documents. And then you have search, just the search service bicep template that you can leverage. And you'll have essentially one template for all the different resources that are spun up. So once you do have this repo provisioned, you will have various different resources within the Azure portal. So right now I have the Azure portal open, and you'll see that we have the app service that was created, the form recognizer cognitive service that was created to OCR and extract the text from PDF documents, Of course, you have your Azure OpenAI service, the search service, app service plan for the web app, and of course your storage to store all of the chunked PDF documents. So when you chunk them, you break them down by page, and you would store them in that blob storage. And you can look at some additional scripts as well. For example, pre-processing docs will have some code base which can help you understand how the pre-process logic works. And there's also other scripts that talk about how to do the document chunking and how to add in additional documents and how to run that PowerShell script again to index the new documents and have them added to your knowledge base for search. And ultimately, once you have this repo spun up completely, you would be able to go to that Azure website endpoint, and you will have an application that looks something like this. So here you can actually communicate with the ChatGPT, which is also connected to your data sources. And just to show you an example of the data that was used, so I just used the same documents that are available in this repo. So there are 6 documents. So let's just click on one just to show you what these documents look like. So pretty standard PDF documents. It talks about the Northwind health plan for this fictitious company called Quintoso Electronics. And I believe all the content is actually AI generated. So it's actually fictitious. It's not actually a real by any means, but it is based off of, I guess, other real companies. But so you'll have different paragraphs, summary of costs, and various different pages. And idea is this would mimic your own data. Obviously, you'd have a lot more than 5 likely documents, right? You'll have thousands of documents, and ultimately that's going to be indexed and stored into the Azure Cognitive Search. And ultimately, I want to get some information out of this interface. So in this example, I'm just going to go with the demo examples here. So what is included in my Northwind Health Plan Plus that is not standard? So the response is in a short paragraph, and it also provides the citations as well. So in this case, Northwind Health Plus offers more comprehensive coverage and so on. So let's click on the citations and see what the actual supporting PDF document is. So it actually gives you an additional way to validate your information. You can actually read that PDF page that the information was retrieved from and use that as validation essentially. You can also look at the supporting content. So in this case, there was just one PDF. Well, there's a couple of portions within the same PDF that were retrieved. So 3 documents were retrieved from that same PDF document. So this is just the standard chunking strategy that was used. So whatever information was within that PDF, it was broken down into chunks for the index. So you're retrieving 3 portions of that. And if you go to the developer setting, you can also increase the number of documents in the search. So let us do that. So first, let's also look at the thought process. So this is basically the prompt, and you have a lot of different information embedded into the prompt, including the three chunked documents as well. And let's go ahead and clear the chat because having history will actually impact the response that we get. And in this case, let us retrieve 6 documents instead of 3. And let's see how that plays out. So the exact same question, what is included in my Northwind Health Plus plan that is not in standard? And now we get an additional citation, and it seems like the response was slightly different as well. It was less verbose than the previous response. So changing the chunking output can impact the type of response. So it's not necessary that you'll get the same response with the same type of chunking or like the number of documents that are passed on to ChatGPT. So in this case, if you look at the supporting documents, you'll see that there are actually 6 documents, and some of them are from different sources as well, such as page 0 and Northwind Health page 22. So different or not the chunk number, like the chunk 102. So there's different sources where this information is coming from. So you have a little slightly larger prompt in that case. So in this prompt, you're including 6 of these documents in the prompt, and ChatGPT will respond accordingly. And let's clear the chat and maybe try asking something else, as what's in my health plan. And the response here is it's saying it's unclear which health plan you're referring to. So it doesn't know. You need to provide full context. It won't just automatically try to respond with the health plan that's in the Contoso document. So I'll need to specify it's for Contoso. That's the name of the fictitious company. So I passed on the name, and now it is trying to look for that answer. So in this case, it provides the appropriate response. We can also play around with a few other examples, such as using contextual summaries instead of whole documents, and also have the application provide follow-up questions as well based on the previous question asked. And let's try this out now with the same what's included in my Northwind Health Plan Plus that's not in standard query. So in this case, you'll notice that same response, there's slightly different variations where you're getting, if you look at the context itself, supporting content, you'll notice that the benefit options to PDF is now summarized instead of the full document. So this actually allows you to fit more content into and overcome the token limit. If you have, say 20 or 30 documents being passed on, then you can overcome that by providing summaries of the documents into the prompt. So in the prompt, you'll notice that the sources are much shorter than they were, much smaller in size than they were before. And you can continue asking follow-up questions. So what's the difference in cost between Northwind Health Plus and Northwind Standard? And it'll give you some of the differences here. This table shows the comparison between the different health plans offered by Contoso, and we can also ask, and then the follow-up is offer any prescription drug coverage. So based on the information, there are follow-up questions being synthesized with the GPT-3 DaVinci model. And there are standard prescription drug coverage. And once again, we can take a look at the supporting content, and it's still the summarized version. And maybe I don't want to use the summaries. I want to use the whole document. So I'm going to uncheck that option and continue asking about what's the preventative care service under standard health plan. So it's talking about dental plans. Very likely. Okay, there's also other components as well, it seems like. Okay, so including physical immunizations and screenings. Okay, that's great. And let's ask one more question. What is the difference in cost again? The same question that we asked earlier. There we go. And let's look at the context. So the response didn't really change too much, but what's important here is that the supporting documents were not summarized when that developer option, so the query contextual summaries, was unchecked. But it just depends on the question and the results. In this case, the response was very similar. That brings us to the conclusion of this video. I hope you all found this information useful. And please don't forget to like, subscribe, and comment. And I hope to catch you all next time. Thank you. Bye.